Okay, hey, welcome here. Hey, I got a question on number 13 from chapter 18. So good to know that a number of you are working forward and getting to this last chapter before the exam. And number 13 is a bit tricky. There's two subtlety points here that can easily get overlooked. So I understand why I got a couple of questions from it. Even though it technically is a black problem, which is supposedly an easy problem, there really is two subtleties here. So hope you caught them, or hope this makes sense here. Let me just read the problem here. It says, two identical loudspeakers are driven in phase by a common oscillator at 800 hertz, and they face each other that is a distance 1.25 meters away. All right, so drawing a picture, it looks, I guess, something like this. This is the first speaker. So I'll kind of make a little paper diaphragm here. Okay, and then on this side, I'll make what is the active part of the speaker, a little paper diaphragm, and give myself lots of room to draw. So here comes the waves. And of course, remember they say the frequency is 800 hertz, okay? And they approach each other. And the question goes on, it says, locate the points along the line joining these two speakers where the relative minimum of sound pressure amplitude can be expected. Go ahead and take the speed of sound to be 343 meters per second. All right, so I'll do all that, but one of the things that hopefully you recognize right away here in this chapter on complex waves is I have two waves that are same wavelength, same frequency, same phase, same speed, same amplitude, but travel in opposite directions. So hopefully all of that triggers in your mind, this is going to set up a standing wave pattern. And of course, then we would be looking for the minimum, so we're going to be looking for nodes. So that's kind of the first thing, and that's probably the most obvious one, and so maybe that's why he labeled it as a black problem. But I think what makes it a little challenging now is, where are these nodes? Or where are these anti-nodes? And they're not easy to spot, especially since a lot of the stuff we did in class, we had things that look like this. We had like a rope or a string, and we tied the string to the endpoints, like a pole or something. And then, oops, looks like I didn't make it level. Let me try that again. Okay, and so we had something that looked more like this. And so if I make a little dotted line, maybe we got a standing wave pattern that looked like this. But what we knew in the problem was where the nodes were based upon the fact that the end was tied. Oh, or we also did the sound tubes. And the sound tubes, we knew the edges were the antinodes. And I really think I got a lot of these questions on this one is because this one, it's like, well, wait, where are the nodes or the antinodes? Because they wouldn't be nodes where the speakers are. That's where the paper diaphragm is going back and forth. But likewise, the endpoints would not be antinodes either, because the paper diaphragm is not where the sound moves the most. This is a little bit, if you remember the waves that we did with the string waves, we didn't get this much detail, but one end of the string was a node where I put the weight, but the other end was the oscillator. And if you'll notice, I never even paid attention to that end because that end moved a little bit, so it wasn't a node, but it didn't move the most, so it wasn't an antinode. And I just stayed away from it. I measured the nodes because I could see the nodes, and I just stayed away from it. Now this one, you've got to draw your own picture here, and that again is what makes it challenging. And so here's the idea and the key to the problem. Let me put antinode right in the center. You see, what's going to happen is the sound waves are going to come, and this one is, the first one is a crest that says move the molecule, okay? Say it, forward. That same one over here is going to say, okay, move it forward. And so as they get right here, oh, and then here comes the second subtlety. Let me erase this antinodes. As I told you, I could have confused you here. All right, but let's this come up, and then they're going to meet because they are the same distance away, and they are in phase. They're going to meet, and this one here on the right is going to say push the molecule left, and this one here on the left is going to say push molecule right, and of course they will cancel. And that would be, and this is where we have our second challenging one, is this would be a quote-unquote a node, but it would be a node for the amplitude wave. Okay? And so that's really, I think, the key to the problem is to realize, okay, where in this problem is either a node or an antinode. But the second piece is, for sound waves, we can label our sound waves as either amplitude waves or as pressure waves. And if you read this, it was very clear. It says the two speakers' relative minimum, so they say minimum, so we're looking for nodes, of the pressure amplitude, not the amplitude. Okay, so I'm trying to point out here that I could conclude where there is a node for the amplitude wave. And since the amplitude wave and the pressure wave are out of phase, when the amplitude node when the amplitude wave is a node, then the pressure wave is an antinode. And that's what I labeled a little too early. And I said this center part's going to be an antinode. But I need to make it clear that it's a node for the amplitude wave, and it's an antinode for the pressure wave. And that's what we're asked to find. We're asked to find the amplitude wave. Now we're asked to find the nodes, and this is an antinode. Okay, so I would say I'm not quite done yet. I've got a little more here to do, but I'm at a good start, because that is kind of my reference point. I have something to work from. Okay, so drawing a standing wave pattern, and maybe I'll just draw the string waves again, but I got to be careful because the string waves are different here than the sound waves, being that the string waves, I know the endpoints are the nodes. And then, of course, it depends what harmonic we're at. So my drawing down here probably would be better if I did something like this. If I imagine the pole right here, where the string is not tied solid, but maybe there's a little ring that can go up and down, and that way, visually, the string being tied to a ring that can go up and down, I could say, well, because the string can go up and down, this is not a node or an antinode. But I know that the center then is an antinode. So that's what I have here. I have an antinode. And this is going to be then the key steps. We are looking for the nodes. We know that the nodes are a half a wavelength apart, so this is a half a wavelength. We also know the center then is a antinode, so we just concluded that's an antinode from the pressure wave. Again, it's a node from the amplitude wave, but it's an antinode from the pressure wave. Okay, so I want to keep saying that. I'm working with the pressure wave. Okay, so my nodes would be a quarter of a wavelength in each direction, and then they would be a half a wavelength repeating in each direction. So let's find the wavelength. That's going to be a big step here. So velocity divided by frequency is the wavelength. So they said take the velocity to be 343 meters per second. Take the frequency to be 800. And grabbing the calculator, 343 divided by 800 gives me a 0.42, and I'll round it to 9 meters for the wavelength. Let me do 2 more steps. Let me take half the wavelength and let me take a quarter of the wavelength. All right, so taking this number and dividing it by 2, I get 0.214 meters, and dividing that by 2 again, so I have a quarter of a wavelength, I get 0.107. Okay, so here's going to be the answer. I'm going to take the middle. Okay, so the middle, as we said, is an antinode. And I am going to go a quarter of a wavelength, 0.107. That right there would be then a node. And then I'm also going to go a 0.107 to the right. And that too would be a node. So there's 2 of them. Now, I need to be a little careful here because they said the speakers were, so let me just kind of put a little edge here. And let me come back to the reading. They said the speakers are what? A distance of 1.25. Let me just read that again. The phase by common oscillator. They face each other and they are a distance of 1.25. Okay. So if I take the 1.25 and cut it in half, this speaker is only 0.625 meters away. So each node is another half wavelength, but I'm not going to be able to keep going forever because I'm eventually going to run out of space. All right. So let me then take this half wavelength, I got a quarter wavelength, sorry, 0.107, and so that's from here to here, okay, and let me add a 0.214. See, so that comes out to be a total distance of 0.321, again, as measuring from the middle. So I'm going to call maybe the middle 0. So the first node would be at a negative 0.107. And the next node would be at a negative 0.321. And I'm thinking another one would fit in here. So let me add 0.214 here. And I get another node, 0.535, and I'll just put a negative. So here's another node. So node. And now the next node's not going to fit. It's going to be beyond that. You can kind of see that if I gave it another 0.2, I'm at 0.7. So it looks like, from counting from the middle, I would have 3 nodes to the left, and then matching on the right, I would have 3 nodes also. So it looks like there's a total of 6 nodes. And to the right, I'll just label them. The first one was the 0.107. Then the 0.321. This would be a positive. And then the 0.535 with a plus. So a total of 6. Do they ask for how many or where are they located? Let me come back here. The line joining, locate the points along this line. Okay, so again, measuring from the middle, and or I guess we could go back and locate from the speaker, but probably it's best to label it from the center, because we know that that is the antinode of the pressure wave. So go a quarter wavelength to the first node, and then a half and a half until you run out of space. So 3 to the left, 3 to the right. These are the locations. Little tricky there. Hopefully this helped.